Okay, so we're talking about rocks and soil. We've talked about the characteristics of rocks or the properties of rocks that we can look at their colors. We can look at how shiny they are. We can look at what kind of color they use when we scratch them across something. We can look at how brittle they are, how easily they break, and their hardness. We've talked about all different kinds of things. So now we're going to talk about soil. Don't read this definition of soil, but in your mind, what is soil to you? What do you think soil is, Anjali?
Kind of like wet dirt.
Wet dirt? Okay. What do you think it is, Caleb?
My guess it's gonna be made out of materials and also glass and food for one instance.
Okay, materials and grass and food. Stephen, what do you think soil is?
Soil.
You forgot. Okay. Yulben, what's soil?
The plant's food.
The plant's food. Okay, foods plants get their food from soil. Chan, what do you think it is?
The wet sand.
Wet sand. And one more. Yedo, what do you think soil is?
Put seeds inside the soil.
So it's something we can grow stuff in. Okay, put your hands down for a second. Soil, technically speaking, it's just the outer layer of the earth that we can grow plants and things in. It's just what's on the outside of the earth. Have you guys ever studied the layers of the earth?
Yes.
The different parts. There's the core, there's the mantle, there's the crust. And the soil is right on the outside of the crust of the earth. And that's what we're going to look at today. We're going to do some soil testing. So before we move on, I want to know what you know about soil. And I want you to turn and tell a partner some of the things that you want to know. And I want you to focus on these things. What can soil do? What is soil? And what does soil need? So these are some things you can use to guide your conversation, but I want you to turn to a partner and discuss this. At your table, you will be talking. Chen, you're not going to be working together. Joel, you're going to be working with Yedo. You'll be working together. You're going to turn and talk to Shastravir about it. And Caleb, you're going to turn and you're going to talk to Sarah and Parag about it, okay? Okay, everybody share with a partner what you think soil can do, what soil is, and what soil needs.
Well, it's the materials, plants, and water. Soil can grow something.
What do you think? Does it need anything?
Okay. Tell me something that soil needs. Chen.
Water.
Water? What else does soil need? Anjali.
Rocks.
Rocks, okay.
Like transformer.
Okay, it needs rocks. What else does soil need, Yulben?
Sand.
Sand.
Minerals.
Minerals. Soil is made up of lots of different things, and soil needs different things in order to support healthy growth in plants. Now, when we took two rocks and we banged them together during our soil tests, Shastravir and Chen, you can turn your chair around. When we banged the rocks together, what happened to some kinds of the rocks? Parag, what happened to them?
They was they're very hot.
There's like dusty stuff that came off of them, right? Now, part of that formation of soil is rocks breaking down and becoming dust. Teeny tiny rocks are something that you would find on the beach called what, Yulben?
Sand.
Sand. So when rocks break down into small particles, they become sand. They also become other sizes of particles. But sand is one of the things that we create. Okay, we're going to look at a few different kinds of soil because there are many different types. This is one picture of a kind of soil. This one would be probably there's a lot of bits of this big pile of rocks that get broken down into smaller soil particles. This is another kind of rock, a big rock, and as it's ground down, it sort of forms a gray dust that's very fine. But there are some particles in this area you can see where you would probably still be able to see the rocks, so it wouldn't be as fine. Anybody know what this kind of soil could be called? This reddish orange soil. What is it, Diego? Any idea?
It's made from fire.
Made from fire.
No, it's made from rocks.
Okay, Chan, what is
The
it?
rocks. If you scratch the rocks, it comes from
Okay.
the red.
The red color is a certain kind of rocks. The word starts with a C. Do you know what that word is? The word is clay. This type of soil is clay. This is red clay soil.
Clay.
That's one kind of soil.
See, that's what I meant by materials.
Is it all
Clay.
together?
They make clay.
This type of soil, this is a sandy kind of soil. It's not a beach, but it's a soil that has a lot of sand in it. You see these light patches? This is a sandy soil, which would make, it would be good for growing some things, but not great for growing other things. This kind of soil, underneath all this green, is what we would call chalky soil. Now we don't use chalkboards anymore in school for the most part. But what color is chalk in its plain old form, Vishwas? It's white. So the chalky soil would sort of have a whitish color and a really fine texture. And it wouldn't all be white, but bits and pieces of this soil would be white and chalky.
See, that's what
This
I
is
meant.
just a kind of mixed soil, all different kinds in a field.
There's a
Right, chalk is on our science bulletin board there. There's some pictures of chalk as well. Okay, this is sand. The picture's not super clear, but you can see in sand that there are different colored, there are different colored particles, which are all from different kinds of rocks that have broken down into smaller particles. So it's not uniform, it's not all the same. It's got many different components in sand. Okay, different kinds of, another kind of soil is called silt. So some of those fields and things we looked at might contain silt. Silt refers to the size of the particles. That's what we're looking for. In this one, you can see bumps in the dirt. But can you see the individual particles very easily?
No.
No. So silt is going to be quite a fine soil. If you looked at it in your hand, the particles would be kind of small.
Excuse me.
What's your question?
Well, sand is made for sand is, and then that stuff is usually made for materials. But
It's made for materials. We do a lot of things with
And
sand.
clay
This is a picture of the clay.
clay.
If you held, excuse me, Caleb, if you held a piece of clay in your hand and you squished it, it would form a hard ball. It wouldn't break apart like some kinds of sand. So clay packs together very tightly. Where else might you have used clay in school? Any idea where you might have used clay in school, Joel? In art, making pots out of clay. It's very similar to the kind of clay you would find outside, but it's been refined. Hold your ideas for just a minute. And then humus. This refers to the particle size. In a humus, which is lots of organic stuff like vegetables that have sort of rotted and decayed away, you can still make out pieces. It's got sticks and leaves, but you can still see the particle sizes are bigger. Can everybody see some of the particles in this?
Yeah.
Now we're going to look at some of these physical samples.
What's the particle?
A particle refers to the size of the things inside that soil sample.
Mrs. Michael?
Raise your hand if you have a question. What's your question?
Well, it's what it say that clay has materials too.
Clay is a material, and clay has very, very fine particles, which we will be
And
able to
that
notice before.
material is dirt.
That is dirt, but all these soils are part of dirt. Okay, we've talked about different kinds. We've got clay, silt, sand, and humus. Okay, and if we rank them in order of their size, it would go clay, tiny particles, silt, a little bit bigger, sand, a little bit bigger than that, and then humus, which has the biggest particles. What do you think this one is? Any idea? Clay, silt, sand, or humus?
Humus.
Which one do you think this one is?
Humus.
Okay, raise your hand. Raise your hand if you think you know. Vishwas, what's your guess? You think this one is silt. Why do you think this one's silt? Because it looks like silt. What looks like silt? What about it?
The color and it's small.
The particles are small and it's a dark brown color. Okay, this one is indeed silt.
Yes.
It would be easier if you could see it beside the humus and you can really tell the difference. Okay,
Yeah.
what do you think this one is? Any idea? Raise your hand if you think you know what this one might be. Shasta, what do you think this one is?
Mud.
Mud? What kind of mud? Made from which kind of soil? Sand, silt, clay, or humus?
I think clean.
Clay. It's got very fine particles, so it just forms like a sticky, gooey mud, and that one is clay. The color is not the same as the red clay we looked at. That's enough of that noise. This one, what is this one? You can look at it. Yuben, what do you think that one is? Do you want me to say humus? Yeah, very good. This one is humus because we can see some of the particle sizes in it. And humus is a very rich soil, which means it's very good for growing things. It has lots of rotten vegetables and plants and all kinds of stuff. And it usually has worms that put air pockets in the soil and also fertilizers. So this is excellent growing material, and we're going to look at some of this in the classroom. What's this one? Let's see. Zoe, what's that one? Sand. That was quite obvious because we know what you do with sand. Okay. I'm going to give you guys a sample of soil. We're going to pass them around, and I want you to look at each kind and tell me, we don't have clay in our class actually, but look at the sand, silt, and humus that I give you, and tell me what you notice about it. What do you notice about the color? Not humans. What do you notice about the color? You can work with the person behind you. What do you notice about the color? What do you notice about the particle size?
This one.
This is the sand.
How do you know it's sand?
Because someone told me.
But if someone hadn't told you, how would you know it was sand?
Because the color is like sand. And it feels like sand. Because it's really.
Oh, okay.
Everybody have a seat?
And it feels soft.
Okay. This one is
Big pieces. This is lots of vegetables. These are big pieces and
Sit down,
small.
Caleb. You're not doing what you're supposed to be doing right now.
Don't make dirty things. Wait, do not put any sand in here.
What did you say?
No, that's not it. We're hunting for worms because Miss Niger said ours has creatures in it.
Oh, yeah.
Silt, you and Diego.
One of the holes in it.
Look at this one through the glass. Okay, when you're finished with one, trade with another group who has something different and tell them which kind of soil you're looking at. How come there's so much sand on the desk?
What is that kind, Rita?
What is humus?
Oh, yeah. How can you tell that it's humus?
Silt? This is sand.
Color, kind of.
And what was the other thing about humus? It had big or small particles?
If there are insects in the sand, it's okay. Don't go digging in that one. I know, that one still has, it's still
What did you guys have?
She has sand.
How do you know it's sand?
Miss Dicty told us. Mrs. Niger told us.
Oh, okay. But how would you know if she hadn't told you that it was sand?
Because it looks like sand.
It looks like sand.
It's a
Okay, pass on the jars to another group.
Okay.
Okay, we do have a clay sample. Everyone needs to be in their seats. Parag and Sarah.
Give it to someone else.
Don't, just hold it at your desk. Everybody look at this one. When I squish it in my hand, what happens? What happens when I squish it in my hand, Edgy?
Feels like a...
So it molds to the shape of my hand, right? Does it break apart easily, Shastravir? No, does it break apart easily, Chad?
No.
You don't think it breaks apart easily. So that is one of those characteristics of clay. Do you think it would be very easy to grow something in this kind of soil?
No. I think it's very hard.
It would be very difficult. Unfortunately, a lot of our fields in Nepal do contain large amounts of clay, and they're hard to farm, and it takes a lot of work to get them to be the right conditions for growing something. Okay, what did you guys notice, those of you who looked at the sand? What did you notice about the particle size in sand? Sarah?
It was like smaller, like a bit smaller.
Small particle size. What was the color like?
It was very like darker than the others.
Darker than the others. Okay. Okay. What else did you notice about? Did you guys notice anything different about the silt? What color was the silt, Shashavir? What color was the silt?
Ours was yellow.
Yellow.
No,
That's not silk.
Was kind of gray color.
The silt was a kind of gray color? What else did you notice about the silt? What about the particle size? Was it bigger or smaller than the sand?
No, it's bigger. Bigger than.
It's supposed to be smaller. There were some bigger pieces in it though, you're right.
Yes.
Generally though, silt would have a smaller particle size than sand overall. What did you guys notice about the humus? Only a few people got to look at it. What did you notice about it, Zoe?
The chunks and the particles were bigger than all the rest.
Okay, the particles were bigger than all the rest. Did the humus look dry or wet?
Dry wet.
Organisms in it. Anjali, are there creatures in there?
Yeah.
There are small insects in the humus.
Robin says he sees one.
Yeah, I've seen quite a few in that jar. This jar is closed because Mr. Bolus wanted you to see that there is, he's the guy who's doing all the kitchen garden up on the roof, that he's working on that project. Inside, there's a lot of moisture in this jar.
Moisture?
Moisture, it means it's wet. He just filled this jar a few hours ago, and it's very wet, so the jar was dry. But this humus is still breaking down. It's still breaking down into soil, so you can still see parts of vegetables and leaves. So when it breaks down, it heats up, and there is steam coming from it as it's working. That's why there's moisture in this jar, and why I wanted to keep it closed, because it's not been cured yet, so it's not totally clean yet. So anyway, I wanted you to see the different things in these kinds of soil. Okay, within soil, if you were to go outside and dig a deep hole about 2 feet deep, you would find, I'm going to have clay all over my head, different layers in the soil. So at the top, we would see a sort of fertile layer, which is good for growing stuff. And as you dig further down, you get more and more rocks and less growing material. Ajit. Fertile layer of the soil would have worms and bugs, and sometimes even like little mice would dig holes in there. There's all kinds of stuff going on in this top layer which helps us to grow plants. This is the best part of the soil. There's all kinds of stuff that's decaying. Chan and Shashavir, stop touching the materials. In this area, there would be lots of stuff to feed plants and to give nutrients to the soil. As you dig further down, the soil gets lighter, and it has a lot less of that decaying matter, the humus, and has more rocks. And the further down you go, you get more and more rocks until you get to bedrock at the bottom, which is good, solid rock down there. Okay? So there are lots of different layers. If you look at the ground on top, you might see one thing, but the further you dig down, the more different things you'll find. Please keep your hands down, slowing down the flow of water. Okay, so if we look at places where we've seen flooding or where the water is standing for a long period of time, we need to think about the question of how water might be bad. If soil needs water, how could water also be bad for the soil, Chen?
In the Police River, they throw this, like, the garbage in the river.
So sometimes what's in the water is not very healthy, and as that goes into the ground, it makes the plants growing in it also not healthy. That's a good point. Zoe?
Like, say, like, it's raining for 2 months straight, or it's raining a lot. And it's like, your plants, there's not that much material underneath that will absorb basically. So it's like, it just, the water starts building up. So that, and then it can actually go in the plants, because if it gets over the level, then the plant will like.
So some plants actually rot. If there's too much water, the plants might actually rot and not be healthy. Some plants, like tomatoes for example, if they get too much water, they start getting this disease called blight, and they can get spotted. Disease will spread very easily through the ground if there's too much water. Anybody ever seen a slug?
Yes.
Or they say chiplokita, I think they say here. That is like a slippery little bug. They like wet ground and they eat the plants and cause all the plants to die too. So there are lots of problems that come when soil doesn't drain properly. What's your question, Maggie?
What if a plant is like here and this was rain? After that, you just put 2 umbrellas to cover it. It only gets a little water.
Well, in Nepal, they do actually build little roofs over the tomato plants so that they can grow plants like tomatoes in the rainy season so that they don't get too much water, because that does actually happen. Okay, now we're going to look really quickly at some soil samples where I don't want you to shake the jar. I want you to look very carefully to see if you can see any little bands of pass the jar on without really shaking it.
Who is it? This is not
What do you notice? Do not shake.
Don't shake it. Do your very best not to shake it.
Why here is water and why here isn't the water?
I don't know. Why? Yeah. Why is there water on the top and not on the bottom?
Yes.
That's a good question.
Okay, can you see that there's sort of a black stripe right here?
Oh, now it's
Right?
getting
It's
it.
lighter,
Because this
water,
you didn't keep a lot of water on
brownish
it.
and black.
So, no.
Like,
Think about the size of the particles. If the particles are big, can the water get?
Why is it not water's
What's happened, do you think? The big particles, this one you can really see it good. The bigger particles have gone to the bottom, and the tiny ones have settled at the top, which means that there's a technical word called density. The water is less dense than this. Yeah, just like our rocks couldn't float, the sand can't float, so the water goes to the top. It's the sand sinks. Okay?
Yeah.
When you lay down in the ground, is it also recording?
When I lay down on the ground.
Don't shake it, turn the jar.
Well,
Okay, we're finished.
what did you decide?
We saw this could in the bottom. This could be all dark,
Yeah.
and there would be more different kinds of soil
Okay.
in
Maybe.
the sand.
Good. Pass it on to the next one.
Joel, can you let me see this one?
Because instead of that, like there's no like a rocky layer, and so it sort of absorbs less. So then the water would just stay on top.
The water stayed on top because the particles were heavier in the other materials, so they would sink to the bottom. And they settled by the biggest to the tiniest. So the clay settles at the top, and the sand settles at the bottom. Sand and rocks and bits like that settle at the bottom. Okay, now we're going to conduct our own soil test. And I'm going to show you how to do it. I need, let's see, who's going to be my time? Sarah is going to be a timekeeper for us, okay? Each experiment, we're going to count for 30 seconds. Do you know how to do that on a big clock?
Yep.
When it starts at the 12, you tell me to go, and tell me to stop when it's at the 6. Okay? It's going to be checking one soil type, which is sand. We're going to look at sand first. So, Zoe, you're going to be my sand holder. I want you to come stand on this side of the desk. And you're going to hold it so it hangs sort of right into the jar. Okay? Just like that. Yep. Maybe hang it a little bit lower so we don't spill much water. Okay, and then I'm going to have a water pour. Ajit, you're going to be my water pourer. And once Ajit is done pouring the water, we will count 30 seconds, and then we're going to measure how much water came out of the sand.
So you're gonna
Okay?
pull it up a little bit.
All of that water.
Okay. Yep, you're going to dump the water in there. Okay, wait till I tell you to go.
Wait. Can you go?
Can you, how about you come on this side of the table? Can you come stand on that side?
That side.
Right here.
Over there.
Right here.
Let's go.
All right.
So right here.
Yep, perfect. Okay, you hold it. Ready? Okay, now pour it in. It's probably not going to run right now.
Just that.
Okay, that was an experiment that failed. We need to try it a different way.
Yeah.
It didn't go right
Maybe
into
we should
the...
try holding this like this. Like, yeah.
Okay, let's try it this way, and we'll try to pour it
Like this.
right into it. And we'll pour it really slowly so that it doesn't run all over. Okay, there we go. And we'll give ourselves 30 seconds and see what's happening. Ooh, look at all the soil that's run down at the bottom too.
Whoa.
Okay. 30 seconds is up. Okay, now we're gonna measure the amount.
Still dripping.
Yep, still dripping. Okay, let's measure. How much is in here? Do you guys know how to use one of these measures?
Yes.
All right.
Yes.
How much water came out in 30 seconds?
22 or 20? 20. No. 20 maybe 25, 26, 27.
Sand.
No, 20.
We got 28 milliliters in 30 seconds. Okay, that's how much drainage came out of the sand. Okay, sit down. Thank you, volunteers.
Okay.
Now we're gonna have someone else. We're gonna have Yato and Joel. Okay.
Who's the timekeeper? Who's gonna be the timekeeper? Tell Sarah.
Come over this side.
But she said
And Joel, you stand there. Go on that side.
Sarah did. Who's gonna be the timekeeper?
The timekeeper this time is gonna be Steven.
Yeah.
Okay.
Can I do it like this?
He's gonna pour it. You're gonna hold it. Like that. Perfect.
Wait, guys.
Stretch it a bit across the top. Okay, I'll tell you when to pour. Wait just a second. And you need to go very slowly and push it into the filter. Ready, set,
Wait.
Go.
Hey, bird.
really slowly,
I'm
slowly,
gonna be
slowly.
Which kind of sand is this? Sand or soil? Sand. So what kind of sand is this? Sand.
Okay, 30 seconds to hold it. Okay, I think we're at our time.
How much is it?
All right, let's measure it.
Which kind of sand is it?
Pour it back in here very carefully.
Oh, more. More this
Okay,
time.
more ran through this one.
I think more this
Okay, so
time.
how many milliliters is this one? 30, it's almost 35, so we would say 34 ml.
Is it
It's 33.
33, yeah, say 33. 30 will be Yulbin this time. So tell him 5 seconds before it reaches the 12. Okay, and pour it right into that slowly. Okay, go.
Go.
Stop the giggling.
Until 6.
Yep. Go slower. Go slower.
Okay, finished. Almost finished. 5 seconds. Okay, nearly finished.
Okay. So this one, we didn't even get to put all the water in the 30 seconds because it doesn't really easily absorb the water.
What is that one?
That one was the silt. That's very interesting. Not the predictions that I would have expected. The measurements I would have. What's that one?
You can't measure it.
Put it down. You gotta set it all the way down. Now measure it again. Measure it again. Nice and flat.
25.
25. Okay.